Alright, welcome back to another fun segment with math. In this video we are going to look specifically at two special cases of lines. They are parallel lines and perpendicular lines. So first, let's start with parallel. Parallel lines mean you have two lines that have identical slopes but very different y-intercept values. So, what are we talking about specifically? Well, we are talking about two separate lines. So, in other words, if we look at your rule, those two separate lines will say that your first slope out of your first line equals the slope out of your second line. However, your first y-intercept does not equal your second intercept. Okay, so when we're talking about rules, that's one of the things that we are talking about. So here I just have two quick little examples. So if you look at this first one up here, notice I have two parallel lines, or at least that appear to be parallel. Now the way that we know for sure if they are is if they satisfy your rule here, that your slopes are the exact same but your intercepts are different. So if we look, both of these lines have already been written into slope-intercept form. Makes them very easy to compare. Here, notice the slope of my first is 3 and the slope of my second is 3. Now in order to verify that they're parallel, we also have to look at the intercepts. So here my intercept occurs at the point 0,8. And in my other line it occurs at the point 0, -4. Since those two intercept points are drastically different, these are not the same line, but they are parallel to each other. Now another way that you could see that would be using standard form. So when we're using standard form, what you have to look for here is that, let me go ahead. So when we're talking about standard form, the rule kind of says that your AX for your first one has to equal the AX for your second, and your BX for your first has to equal BX for the second. However, your C for the first does not equal C for the second. So that is kind of what you're looking for when we are talking about rules in terms of standard form. So if you look at these two lines here, again notice they visually look to be parallel. Here I have 3x plus 2y. If I look at my second line, I have a 3x plus 2y that satisfies the first half of my equations here, or my formula. But if you notice, my two C's do not equal each other. My first one is a 12, my second one is a 6. That satisfies the second part of my rule. Therefore, these two lines here would be said to be parallel. Alright, if you thought that was a lot of information, let's talk about perpendicular. Perpendicular lines, again, are talking about two lines, but instead of being the same slope, these ones have opposite reciprocal slopes. What that means is that these two lines are going to cross each other, but they cross very specifically. They cross at a 90-degree angle. So in other words, your slopes have to be opposite reciprocals, not just simply opposite. Okay? Now, the biggest rule that we use in order to test this, or the easiest one to use, is this one here, where we have that you're going to take your first slope, multiply it by your second slope, and you're looking to see if they equal -1. If that is true, then you have perpendicular lines. If that is false, then you do not have perpendicular lines. So here with perpendicular, The only thing that matters is your slope. So if we look at this first example, notice again I have this red line and I have this blue line. And they appear when you look at them like they're perpendicular. So to test it, we have to look at the slopes here. So when we're looking at slopes, my first slope here would be a 3. And my second slope would be the negative 1/3. So the rule says I have to take them, my first times my second, and I'm looking to see if this equals negative 1. So here I've got 3, and I'm going to multiply that by a negative 1/3, and I'm looking to see if this equals negative 1. Well, 3 times negative 1/3 means negative 1 equals negative 1. Therefore, that's a true statement, which would mean that these lines are perpendicular. Now, one cool thing just to keep in the back of your head is that if you have a vertical line, so an x equals equation, and a y equals equation, so a vertical line and a horizontal line, that means perpendicular, always and forever. It's just fact. Okay? So, as a fun thought, what that means, according to the rule, is if my first slope was 0 and my second slope was undefined, then the rule says that 0 times an undefined has to equal negative 1. Well, we have to look at what actually constitutes undefined. Undefined says you're dividing by 0. So we would have, say, negative 1 divided by 0 gives you negative 1. Thus, that is now a true statement, because theoretically your zeros would cancel, leaves behind negative 1 equals negative 1. So if that doesn't mess with your brain, I don't know what will. But as just a fun side, I always like to remember that 0 times undefined equals negative 1, which means perpendicular. Alright, now that I'm done messing with you, let's actually do a couple examples here so you can see how these work. So this first example says that you have to physically determine if your line is parallel, perpendicular, or neither. So what does that actually mean? Well, it means that you have to test your parallel rule. You have to test your perpendicular rule. And then, if neither test works, the lines are neither. So that's what we're doing. Now, if you look at this first one here, this is my first line. So before I can even run my test, I have to rearrange my line. You want to change each line into y equals mx plus b, or ax plus by plus c. Okay, either form would work. My recommendation is to use slope-intercept form. It's usually the easiest one to decipher, but either one would get you there. So we have 2x minus 3y is equal to x minus 1 minus y minus 3. So the first thing I need to do here is I need to take this negative and distribute it through my back parentheses. So this is my 2x minus my 3y is going to be x minus 1 minus y plus 3. I can combine my two like terms. So I have 2x minus 3y is equal to x minus y plus 2. Now with this, I would put it into slope-intercept form. So to do that, says I'm going to take this 2x and I'm going to move it over. Since it's positive, moving it says I need to subtract. Leaves me with negative 3y is equal to 1 minus 2 is a negative x minus y plus 2. I'm then going to take my y and shift it. Since it's negative, this says I have to add. So negative 3 plus 1 gives me a negative 2y is equal to negative x plus 2. Then divide everything by negative 2. So y is going to be 1/2 x minus 1. So this is my first equation. Now what I need to do is I need to use my second equation. So I have negative 2y minus x equals 9. I'm going to take this x and I'm going to move it over. So negative 2y is equal to x plus 9. Divide everything by negative 2 and y is going to be negative 1/2 x minus 9/2. So in this we have to identify the most important pieces, and that is we care about your slope. So the first thing that we need to do is we have to test parallel. Again, parallel says my first slope should equal my second. My first slope is 1/2. My second slope is negative 1/2. And do these equal each other? Well, they do not. Therefore, you're not parallel. If you fail the parallel test, then you need to test your perpendicular. The perpendicular test says take your first slope and multiply it by your second slope, and you should get negative 1. So my first slope is a 1/2. My second slope is negative 1/2. And when I multiply those together, it does not equal negative 1. Instead, I have negative 1/4, which is not what I wanted. Since I fail both tests, then that means the conclusion you have to make is that the lines are neither. And this is the answer to your problem. Okay, let's look at another one. So here I have these two lines, and again I'm doing the same thing. So I'm going to start with this equation. So I have 3 minus 2y plus x equals 7 times x minus y. I'm going to take this negative and distribute it through. I'm then going to take this 7 and distribute it through. So this becomes 3 minus 2y minus x is equal to 7x minus 7y. Now I need to get my y totally by itself. So I'm going to go ahead and take this x and move it over. It is negative, so I have to add. I'm also going to take the 3 and move it over. Since it's positive, that says I have to subtract. Leaves me with a negative 2y is equal to 7 plus 1 gives me an 8x. And then this is minus 7y and minus 3. I need to take my 7y and again move it. Since it's negative, to move it says I have to add. 7 minus 2 gives me 5y equals that 8x minus 3. Divide everything by 5, and y is going to be 8 over 5x minus 3 over 5. So that being said, that's my first equation. Now what I need to do is solve the second. So my second equation says I have 5y plus 1 all over 4 is equal to 3 plus 2x. The first thing I want to do is get rid of my fraction here, so I'm going to multiply everything by 4, which says the 4 has to go to all parts. 4 over 4 is going to cancel and leave me with 5y plus 1. 4 times 3 is 12. 4 times 2 is 8. I'm then going to take this 1 and I'm going to move it over. So this becomes 5y is equal to 11 plus an 8x. I then have to divide everything by 5. So y is equal to 11 over 5 plus 8 over 5x. So now, just like before, the first thing I have to do is I have to recognize what are the important pieces. So here's my slope, and here's my slope. So to start with, I have to test parallel. Again, that means my first slope should equal my second slope. Well, in this case, my first slope is 8/5. My second slope is 8/5, and these are equal. This leads me to believe that they're parallel lines. However, I need to look at the second piece, and the second piece says that my first intercept cannot equal my second intercept. So here, my first intercept is the point 0, negative 3/5. My second intercept is going to be the point 0, 11/5. These clearly do not equal, therefore the lines are parallel. And this was my answer. Okay. A different type of perpendicular parallel question that you may see looks like this, where it says that you can use the idea behind parallel and perpendicular in order to find equations of lines that satisfy those definitions. So first, it says find the equation in slope-intercept form for the line parallel to the given line and passing through the point. So, what do we know? We know the form that we want is slope-intercept form, and we know the type of line that we want is parallel. Given that information, the line I have to work with is this one here, and the point that I have is that one there. So the first thing that I have to do is I have to make y-intercept out of the given line. So I'm going to start with 2 times that y minus 1 plus x plus 3 over 5 equals negative 7. I'm going to start the whole thing off by getting rid of my fraction, which says multiply by 5. That means, again, I am multiplying all 3 parts. So here, this is going to become 5 times 2 times y minus 1. My 5 is going to cancel, so plus x plus 3 is equal to 5 times negative 7 is negative 35. Do the math here, and this gives me a 10 times y minus 1 plus x. I'm going to go ahead, move the 3 over. So this is going to equal negative 35 minus 3 is a negative 38. I'm going to distribute, so this becomes 10y minus 10 plus x is equal to negative 38. I'm going to move my 10, which says I have to add. So 10y plus x is equal to negative 28. I need to move my x over. So I've got my 10y is equal to negative x minus 28. Divide everything by 10. So y is equal to negative 1/10 x, and then minus 28 over 10. Now in this case, I want a line that is parallel. So I have to use the rule. Okay, so I want to use the rule that my first slope equals my second slope. Okay? So here, if I want to find a line that is parallel, then the slope that I am using is that my first slope is negative 1/10. Therefore, by the rule, that's also my new slope. The point that I have is the point negative 5, 0. So after you figure out your new slope, you need to use your point slope to start with. So y minus y1 equals m times x minus x1. So here the important pieces that we have is that m is equal to negative 1/10, and we have that x1 y1 is equal to negative 5, 0. Plug what we know into our equation. So we have y minus 0 is equal to negative 1/10 times x minus a negative 5. With that, make sure you remember minus a negative is the same as positive. So this becomes y is equal to negative 1/10 x minus 5 over 10. And in this case, we have to reduce. So here, we need to reduce it all the way down. So this becomes y equals negative 1/10 x minus 1/2. And this was the line I was looking for. So as you can see, this line is parallel to the line I started with, and it has completely different y-intercept points. Therefore, I answered my question. Alright, so that one we did was parallel. So if we look closely at this one here, notice again we want slope-intercept form, but we are asking for perpendicular. Again, we have given an equation to start with, which is this equation here, and we're giving a coordinate point. So we are going to start or run this the exact same way that we just did the other. You have to start with the line you've been given, so that's 4 times the y plus x minus 8 times the x minus y equals negative 1. We need to distribute, so you're going to distribute through into both parentheses, and here you need to make sure not to forget your negative. So in the first one, we're going to have 4y plus a 4x, and then distribute negative 8. So this becomes a minus 8x plus 8y equals negative 1. I'm going to combine my terms together. So I have 8 plus 4 gives me a 12y. 4 minus 8 gives me a negative 4x. And this is equal to a negative 1. I'm going to take my x and I'm going to move it across the equal sign. Because it's negative, I have to add. So here this becomes 12y is equal to 4x minus 1. Divide everything by 12. And y is going to be 4 over 12x minus 1 over 12. I need to make sure that I reduce the slope. 4 over 12 can simplify down, so this really becomes y equals 1/3 x minus 1/12. Here I need to now use my rule for perpendicular. So I'm going to use the perpendicular rule, which says take my first slope times my second slope should give me negative 1. Well, that being said, the other way that you can write the rule is I only have one slope. Therefore, in order to find my second slope, I have to take negative 1 and divide it by your first slope. So in this case, what do we know? Well, we know that my first slope was equal to 1/3. So my new slope, or my perpendicular slope, is going to be negative 1 divided by 1/3. Well, we know, keep the first, change the multiplication, flip the reciprocal. So my second slope here equals negative 3. So this is the information I need. Here is my point. So I've got my slope, I've got my point at 6, 10. So all I have to do here is start with point slope. Y minus y1 equals m times x minus x1. So here this becomes y minus 10 is equal to negative 3 times x minus 6. Y minus 10 is equal to a negative 3x plus 18. So y is equal to a negative 3x plus 28. And here is my perpendicular line. So notice between these two lines, my first slope is 1/3. My perpendicular slope is negative 3. Notice these are opposite reciprocal slopes. Therefore, I have completed my answer. Alright, so there you go. That in a nutshell is everything you would need to know in order to get started with parallel and perpendicular lines. Remember, your key definitions to parallel mean same slope, different intercept points. Your key definition to perpendicular, opposite reciprocal slopes. As long as you remember those two definitions, you should be able to find lines that are parallel or perpendicular, no matter what information you've been given. So if you have any questions, please don't hesitate to let me know. Otherwise, keep smiling, relax, have fun, enjoy your parallel and perpendicular ideas, and as always, I'll see you next time.